welcome to our next lesson of our acids and alkalis topic. So for your do now task, I'd like you to consider the following images and think about what they all might have in common. So pause the video whilst you have a think. Okay, we then have a home experiment for you to do. These are the things that you will need in order to be able to do this acid and base experiment. An everyday acid, so something such as lemon juice or vinegar, will work nicely, and then an everyday base such as bicarbonate of soda or baking powder, which you might use for cooking, or as a last resort, an indigestion tablet, so if you crush that into a powder first. So in order to do this experiment, you take a tablespoon of that powdered base and add it into a cup or a glass, and then slowly add little portions of your acid to that everyday base. And the key point that I want you to be focusing on here is, what do you notice? So with this experiment, if you're not able to do it at home, I have recorded myself doing both this experiment but also that indicator experiment, although I used red onion instead of red cabbage. You will be able to find those by using that hyperlink there. So thinking about what you notice from this experiment between that everyday acid and everyday base, because these bases are a certain type of base which we are going to be focusing on for this lesson. So pause the video whilst you have a go at that, or watching the video that I've linked in here. Okay, so we're going to be looking today at the reaction of acids with metal carbonates. Please read through the worksheet that I have attached on Go for Schools so that you can be looking out for the information that you need to write down and pausing the video yourself in the relevant places. And this is the type of base which we were just talking about for that home experiment. So example being bicarbonate of soda, that is also found in baking powder, which is why baking powder could also be used, but also sodium hydrogen carbonate, that's what's often used in indigestion tablets, and therefore why they could be used in that reaction. So this question here, so metal carbonates produce a gas when added to acid. How can you tell this? So this is hopefully what we were able to observe through that home experiment or through watching my video. And so the answer here is that you would have seen some bubbles of gas. You might have said it fizzed. But our more technical term is something called effervescence. So effervescence is the word we use to describe when a gas is produced in a reaction. And that effervescence tells us that a gas has been produced. So carbonates are a type of base, as I've said, and therefore they are going to be able to neutralise acids. Thinking about this word, carbonate, that indicates to us that they contain carbon, but they also contain oxygen. Now, the key bit we want to focus on is this carbon, because that carbon there is what's going to determine the nature of that gas that gets produced. So we end up producing carbon dioxide, which is a gas I'm sure you are familiar with, because it gets produced during respiration, and so we breathe out carbon dioxide. Its chemical formula is CO2 because it has one carbon and two oxygen atoms. It's also used in fire extinguishers. You might have come across those before. So a key part here is we know that a gas is being produced, but we need to be able to confirm that it's carbon dioxide in order for us to say that it is a carbonate that we had to start with. And what we use is a substance called lime water. So lime water is actually calcium hydroxide. And this is a colourless solution, and on reaction with CO2, we end up producing calcium carbonate, which is chalk. And as I'm sure you're familiar with chalk, this is a white solid, and therefore this causes our lime water solution to turn cloudy. So if carbon dioxide is present, our lime water turns cloudy. So a few questions then for you. Calcium carbonate reacts with an acid to produce a gas, which turns lime water cloudy. What is the name of this gas? And then secondly, the other product of this reaction, just like our other neutralization reactions, is a salt and water. So complete the general word equation for the reaction of a metal carbonate with an acid. So that's what you're starting off with. What are the three products produced from this reaction? So this is just a recap from our previous lessons. So our salt endings depends on the type of acid. So we looked at that when we were naming salts. So hydrochloric acid forms chloride salts. Whereas sulfuric acid forms sulfate salts. Nitric acid forms nitrate salts, and that's what determines the ending of our salts. So the way in which we name our salts, just like what we looked at last lesson, for our salt we want to be considering the metal and the part of the acid in order to name that salt. So in this instance, the first part of our salt is our copper, and our second part, the part of hydrochloric, is our chloride. So what we then get is our copper chloride plus water plus carbon dioxide. So you now have some word equations to practice. We have just walked through that first one, and so you should apply the same principles for the following 10. So ask yourself what the metal is and what the acid used is. And in each of these reactions between a carbonate and an acid, we are always going to be producing carbon dioxide and water. I'm going to set up an assignment on Teams so that you can submit your answers to these 10 word equations. If you do have any questions, do send me an email or a message on Teams. If you use the @nbailey, then you will get a faster response, as I get those notifications faster than the emails. Thank you all for watching, and see you soon.